Okay, so today would be the final day of the data visualization with Python course. I hope you guys have enjoyed it so far. So until now, we have discussed various techniques in which we start with line plots and then bar plots and polar visualizations. Moving ahead, we went with the scatter plots, and finally, we're coming to our final day where we are going to discuss the storytelling and map visualizations. So the first session will be taken by me, first half of the session, where we will be looking at how do we create something which is animated and this incentive as what you're seeing right now. Like this is such an insightful um, plot where we get to know a lot of data regarding the wealth of countries and how it's correlated with the population and the life expectancy over multiple years. And basically, this is called as multivariate analysis. So I hope that you remember from my previous class that I had explained about univariate, bivariate, and multivariate. So this would be multivariate analysis. Okay. So, okay. So let's start with going through the code. It's nothing new since you have already attended the previous classes. Like it should be fairly simple for you to understand. So let's start with the imports where we import Matplotlib, Pandas, NumPy, and Alter. So I think Alter would be new if you haven't gone through the code that we have shared on your own because we hadn't covered that during the session. We had covered the other three types. So I'll explain that in a little bit more detail so that in case you haven't gone through, you'll be able to understand that as well. Okay. So once we are done importing, we create a dictionary called plot style where we set all of our style related parameters. So we update use text size, font size, label size, DPI, figure size, and title size. So first we're going with the Matplotlib approach. Okay. And once we have done that, we are going to use plt.style.use ggplot. So ggplot is what we are always like using from the start since it's quite uh, good in terms of attracting the eyes and it has some sort of clarity and it gives a contrast so people can see it and understand it as soon as they have a look into it. And then we update our RC params with the dictionary that we created earlier. Okay. And once that is done, we have our main path over here where we have the data set. Okay. And once we have this data set put up, what we're going to do is we're using pandas.readcsv in order to go through and convert this into a pandas data frame. Okay. So using the raw data.shape, we're going to look at how many rows and columns there are. We have these many rows and these many columns, right? And when you use the dot head function, what happens is we're going to see the first five contents of the entire data frame or the data set. So you can see that we have country, year, population, income, life expectancy, and continent, right? So I would like you to put up in the chat or unmute yourself and tell me which of these would be numerical and which of these would be categorical variables. Can anyone share that? So the question is, in this data set, which of these are numerical variables and which of these are categorical variables?
Please put your responses in chat or you can directly speak up. Shahad has
Yeah,
given us.
correct. So country is categorical. Uh, Year. Okay.
How do you say, Shamshad, year is categorical? Uh, Life expectancy is also. No, no, no. How is it categorical? Uh, if actually there is a less than greater than relationship between them, then it can be numerical. If they are different names, right, then it is categorical. So year 1800 is less than year 1801. That is why the year column is numerical, not categorical, right? Life
Yeah.
expectancy is also a number in which 28 is less than 29. That is why life expectancy is also numerical. Country and continent are categorical. Afghanistan is not less than any country. We cannot have such a relation.
Yeah, I thought
Okay.
maybe we could put them in buckets or um, some kind of bins, right? Like
How can you
for this,
put, yeah, you can put year in bins as a like as something to differentiate. That's correct. But categorical variables is something you categorize it with, like a
right?
country. When there is no relationship. So, for example, yeah, when we go to the dot describe, right, and raw data dot describe is a inbuilt pandas functionality to let you know what is the statistics regarding the data. Now, when you see, we get NAN for country, right? Here, mean, all these. Whenever it's such a case, this would be like not always, but most probably this would be the categorical variable. This and this, okay? Because we are getting the numerical data from the others. We are getting the statistics. It's a very simple way to differentiate if you're not going to analyze the entire data sets manually. Okay, so now that we know, so we have seven different uh, columns over here, and since we have done a transpose, it comes to the rows now. So what is this unnamed zero? What is that to? It looks like this unnamed zero is just a repetition of the index that Pandas has created, right? So this would be redundant in terms of our usage. Moving ahead, we have country, which would be a categorical variable. Year, population, income, life expectancy, and finally we have the continent. So there is some sort of relationship, even though it's a categorical variable between the continent and countries, because the continent they can contain multiple countries. Like Asia, it contains India as well, right? So it has China also. So all of those would come under Asia, and all of these can be taken as numerical variables. Okay, so let's see how do we go ahead and create a plot of such meaningful insight and go ahead. So what we do is we first come and drop the unnamed of 0 uh, column. So unnamed of 0, it is a repetition, right? So we are just going to drop the data frame, and since it's axis 1, it signifies that it's a column. Okay. Now once we drop that particular variable, we are going to rename the continent into continent. Can someone tell what's the difference here? What are we renaming what as? Like, what's the point of this particular line that's being highlighted right now? Like, why are we even doing this? The rename from continent to continent. You can put up your answer in the chat or unmute and share the answer. Hmm, what do you mean by for display?
Like when we are showing it in different places, right?
No, like, what's wrong with, no, what is the meaning of this sentence? Like, why is it necessary? We're renaming. There is already a continent here. Why do we have to rename this?
I think we can do without renaming too, right? But this is so that
Yeah,
when we are showing it in graphs and charts later on,
okay.
then the name should be with uppercase letter.
No, we're changing it from uppercase to a lowercase, okay? So usually we have all of our variables with a lowercase. So to make it consistent, we are
Consistent.
renaming it throughout. So probably it won't be that relevant in terms of data visualization, but when we come to data preprocessing for machine learning or deep learning or neural networks, we always follow this convention where we have a smaller lowercase, right? So in terms of that, it has a lot of significance. So we are going to maintain this consistency by renaming continent to continent. Okay. So that's why we are going to do that. Going to do that. And so let's move ahead. And now we're going to start plotting a basic data. Okay. Uh, once uh, so how are we going to plot a basic data? We first create a copy of the original data into data. Okay. And then the data of continent is equal to raw data of continent as type category. So why are we doing this? The particular continent category, right here, continent, it is not by default assumed or calculated by our data frame as a categorical type. Of course, we do know that it's a category. So when we explicitly set this, when we convert these continents into a particular code, right? So if any one of you had attended our previous data wrangling course, we had some categorical preprocessing which was done. And in that, we convert them into numbers, right? So what would this be called? We had ordinal encoding, one hot encoding, etc. So in that, we had label encoding for people's names, if any one of you were there as well. So why do we do label encoding? So that any unique uh, any unique category will be given an associated number after performing a sorting. So Africa would come in the first, because when you sort all the continents, Africa would be alphabetically the first one, then comes Asia, then comes Europe, and so on. Okay. So that's the alphabetical ordering of these, and then they're being given uh, an index. So that is done by this particular line, and we are adding that to the data frame. And moving ahead, we are going to filter the data by year. So for making a single one plot, the first plot, we're going to filter it by year, and we're going to display only for the 1982. Now, once we do that, we're going to show the data frame. So that's what is seeing here. As you can see, in the continent, we have continent codes as well with their respective numbers or indexes. Now, we are going to plot this as income versus life expectancy. This would be just two of our categorical variables for the year 1982. So how do we do that? Using plt.scatter. If you were attentive in yesterday's class, this syntax would be extremely familiar, where we mention X as a data frame of income, Y as a data frame of the life expectancy category, and alpha would be for the transparency, and H color for the surrounding color. Okay. And we have some labels X, label Y, and title, and title layout for a compact dot of the same thing. So moving ahead, as you can see, we see a lot of clustered data towards the left and very few data towards the right. Okay. But didn't we see that our particular data set has much more data than this, right? We also have the information regarding the population, and we have the country and the continent. We are just plotting here for a given year the life expectancy and income, the income versus life expectancy plot right now. We are missing three essential categories as of now, right? So how are we going to do that? So in order to do that, I'll create something like this. Let me go through what's happening right now. The similar color will be given for the same continent, and a different color will be given for a different continent. And also, these circles are big in some places and smaller in some places. So that size of the circle is because of the population of that given country. Okay. So before going into it even more in detail, let me just explain you the code. Okay. So we have plt.scatter. XY remains the same, but we have we have three additional parameters that we are giving to the same plot. So S would represent the size. Okay. So size of population, and we are normalizing it by the maximum population in order to have a reasonable scale. Now, once we do this, based on the population of that particular column, I mean, of that particular row, we are going to have a equivalent size. So in this particular year, whatever the population is, that would be directly proportional. Okay, the size of this circle would be proportional to that particular population of that country. Okay, and C, color would be dependent upon the continental codes. So it is because of this continental codes uh, as the color variable that multiple countries will have the same color, right? So that's how we are going to plot this. Now, once that this is done, don't you see even now that a lot of data is more clustered towards the left, that we cannot like really identify the relationship between these countries towards the left. I mean, there is one over here and one over here, but this is the main data. This has the majority of the data. So how do we do that? So first, before we go and analyze and make any changes to the main plot, let us analyze this particular data where we see how is the variation of life expectancy versus the income. And how do we do that? We do that using our bar plot, right? Because bar plot can help us put a particular bin size, and we can see what is the frequency of the plots in that particular bin size. So when we do that, in that when we plot the income, right? When we plot the income, we can see that most of our data set is lying in the initial bin. That is when we put a bin size of 20. When we do that, most of our data is towards the leftmost bin, and it's reducing in an exponential manner. What does this mean? It has a logarithmic relationship, right? It's extremely skewed towards the left, and it's showing exponential relationship. So what do we need to do in order to make this even more understandable? To do that, we can plot the same thing but in a different scale. That would be a logarithmic scale, so that with the help of this exponential we found out that this has an exponential plot, right? So when we plot it using a logarithmic scale, the same thing over here is going to come more spread out evenly towards the right. Okay, so we will be able to analyze and understand it in a much better way. So don't you think that whatever there was too clustered towards the left is much more understandable and interpretable right now? It is much better for us to see and visualize and understand, right? So how do we do this? In order to do this, we just add a single line, right? That would be x dot plt dot x scale as with the variable log. It's as simple as that. With just this one single line, we're able to give we're able to obtain a much better plot than we have before. Okay, so once that is done, right now we don't know what is this continent, what is the blue one, what is this pink, what's the purple, what's the yellow. So what do we need to do? Here we are going to add a legend. Okay, so to add a legend, once we add a legend, it's going to look something like this, where we have the corresponding color and that particular um, continent which is associated with that particular color. To do that, let me show you how are we doing that in code. So the bubble, till now we had a plt.scatter which was not put into a variable. So now once we put that into a variable called bubble, we are going to do something called as handles comma label equals to bubble dot legend elements, right? So this is going to be used for creating our legend, where we have the number over here, right? It's a variable, and here this is a string. So we have a list and a string here. So the handles will be given here, and the data of continent with categorical as cat dot categories is going to help us enumerate and plot this. Okay, so and finally the location is going to be upper left. So once that is done, is going to plot those. See, we're going to group those things by number, and we're going to give them the string through data of continent with cat dot categories. So it's as simple as that. By just adding these many lines, we are able to get a fairly good legend over here. And moving ahead, let's animate the same thing and create something like this. Like, wow, isn't this so insightful? Because we're able to see how each of these countries are changing and evolving over time in terms of population, in terms of life expectancy, in terms of income. Like it's so different when it starts in 1820, and as it goes towards 2025, or actually this particular data set is projected up to 2050. So we have 25 years additional to what we have right now, right? So it's going to be projected up to that, and we'll see how to do it. So we first set the scale of the scale of the figure and also its DPI. Then we use the style as ggplot and update it with our dictionary we created earlier, right? Once that is done, all of this remains the same. Okay, we have scale equals to population, color equals to continent codes, CMAP is just like a color palette. Okay, so alpha is 0.7, that is the transparency, and edge color white. Then we have the legend setup over here and the main plot. Now, do you see that we have this bubble over here? Is going to be used for making changes to the entire plot over time. How are we going to do that? So the changes comes only from here. Okay. So to do that, we have an update function. Update. We have an update function which inputs a frame. Now this year over here, right? It is 1800 plus the frame number because the first frame would signify 1800, right? So we're going to create the year based on that. And then we have bubble dot set offsets with df of income comma life expectancy. So basically we're creating offset for each and every single year, and we're just making that particular change for the upcoming data frame, and that's going to be updated in the plot. And once that is done, we have to also change the size of the circle, right? That is, the if there's a change in population, the circle has to be bigger if it's an increase in the population, and vice versa. So we do that using the set sizes. Once we set the offset and the sizes, we're going to just plot the title, which at the center you see that it's changing, right? That's going to be changed, and we're going to plot it. Now, once we have this particular function ready, we are using the func animation function in order to create this particular plot, which is varying over time. This just needs a couple of parameters inside. So uh, when we give figure over here, which we have set initially, that is figure equals to plot figure with the particular aspect ratio, it is important because it maintains the entire scale throughout the animation, right? Otherwise, imagine this going small and big based on how the plot is. That would be really absurd. So to not let that happen, we are setting the aspect ratio, and we are giving the update function. And to this update function, we are giving the data frames and the intervals. So this is going to take care of how much time the delay is going to be between each frame and the number of times you have to call that function. And after that, we're just going to save that as a GIF, and we're displaying the GIF right now. I think this code is fairly uh, like easy to understand. Did you guys have any doubt here so far? Has everyone understood it? Okay. Others, any doubts? Okay, let me consider that as a good sign that you all have understood what's going on, and let me move ahead. So we'll be seeing how we can plot the same thing using alter. Okay, so we will create something like this, but however, there's a difference here. Alter is little more interactive when compared to Matplotlib. Hence, when we see each one of these circles, right, we do not know which country it is. We just know from the legend that it belongs to a particular continent. But in the case of Altair, when we hover our mouse on top of it, we know that this belongs to China and this belongs to India. And we have the other countries as well here as a smaller sized specs, which depends on the population, right? So how do we plot that? We now, in order to do that, we are creating an alt dot chart with the data frame as an input. We mark the cycle with opacity of 0.7. Now we start the encoding. This is the main part of the entire alter code. Here, the first section is for alt.x. That is for the x-axis. What will we do? We have a variable called income colon q. So when we do that, it's going to automatically from that data frame select income as the x variable. Now we scale that in a logarithmic way with a base of 10. So in this, unlike in Matplotlib, we have to explicitly mention the base as 10. Okay. Now for alt of y, that is the y-axis, we set it as life expectancy. And Since the scale is just a normal scale, there is nothing there. Now, the size, altered size, pop q. So what does this mean? We have to change the size of these circles that's there based on the population. So we're giving population as the variable for that, and a legend is dependent upon that particular countries, right? So we have a legend where these dots also have a legend. So the circle, the bigger it goes, we know what kind of a size that goes to, right? Here we don't know what's the scale of the circle. Till now, we didn't know if this circle is like 1 lakh or like 100 crores or a billion, right? Or 100 billion. We don't know that. How do we do that? We need a legend for that, right? So that's being done using this legend. And finally, tooltip is the reason why when we hover our mouse on top of it, we are able to see the particular country. So tooltip equals country and color equals to continent. And by default, we have the legend for continent. And finally, we have the properties where we set the aspect ratio and the title of the entire plot. So once that is done, we need to make these circles bigger because that was not that visible, right? In order to do that, we are just going to set this range of these sizes from 2 to 8,000. So it's a linear scale that we have chosen, as you can see in the legend here. But don't you think that now, even though this particular plot is much better than before, the legend over here is like overshadowing the whole plot. It's like attracting the eyes of the observer more towards this side also, when the main focus is supposed to be towards the left side. So what we're going to do, what we're going to do here is use the tooltips. Okay. So using tooltips, we are going to mention that particular population on the hover itself, and that is done by a simple method where we have a title of population, and we are creating a list, okay, for the tooltip, where the first tooltip was country from previous way, but we are giving a title now as an additional category, as an additional parameter, so that when we hover on top of it, we have country as well as population, and people should not get confused. I mean, even though it's fairly evident that China would be the country, we have to give it a proper title, right? So we have a title, and the same way we have population with the format as an additional display item here, and we are going to give it the population. So I hope it's simple till now. Also, we are able to follow through, and you see that the legend here is gone, and we have the data embedded into the tooltip, right? So there's no loss of data as of now. And finally, we go ahead and we give the titles. So what's happening here, right? 1 second. We are changing this X label and the Y label here by explicitly mentioning the title for alt of X and alt of Y using the title of title parameter to each one of these. So here we give income GDP per capita, and here we're giving life expectancy in years, which is going to be given here. But until now, it was by default taking whatever the variable name was there in the data frame, right? The categorical name, it is directly being displayed over here. So once we change that, we're going to start making a much better plot where we're trying to mimic what we had an animation, right, in Matplotlib before. So we're seeing the evolution of each one of these parameters for each one of these countries over the years. And we have a slider for the same thing. Okay. How are we going to do this? We have to create a slider which alters the year, and it's going to update the entire plot using alter. Let's see how to do it. So when we start here, we first create a slider. Okay. Before that, we also have a years list where we can create the limit, that is from 1800 to 2050 with a step of 1 using np.arrange. Now we create a slider. So the slider, this defines a year slider that the user can drag. It ranges from 1800 to 2550 as we have set in the parameters, right? Now, because we have name is equal to year, it's going to help us vary that particular variable. Moving ahead, we have the selection. So what happens here? It binds this slider to a selection filter on the year. So whatever value is given by the slider will vary the variable year, and by default we are going to show the particular value of 1950. Then we have population min and population max, so that we know what the minimum and maximum population across the entire data set is, and it is used to scale bubble size consistently across the years. Otherwise the scale will vary, like the size, each of these circles, right, is going to have a scale based on a particular data frame, not all of the years. So in order so that we keep it consistent throughout all the years, we need to find the min max from the entire data. So that's the reason why we're doing this. Once that is done, we start creating our chart where we have mark circle, where the circle bubbles represent countries with a white border, right? Once that is done, we have the dot encode where we start to display the income in the x-axis, and the scale is altered scale logarithmic with a base 2 and a domain of 100 to 1 lakh, right? So why are we doing that? We're doing that so that we set the limits for the x-axis. Now once we are done with the x-axis, we do the same thing for the y-axis, where we also have a limit for that as well, from 10 to 90, and here you can see it's up to 1 lakh. Even though it's not shown in the grid here, it's moving out over here, right? So yeah, now we'll go ahead and we'll change the size based on the population using the min max that was calculated previously here, and we have a range also for the same. Now the color, this variables remains the same, where we are giving the legend as a continent, and we have the tooltips, and these tooltips remain the same as previous, where we give country and the population as well as a parameter. And finally, we have the properties. In properties, we have the width, height, and title. Now once all of this is done, we add a parameter. Okay, we add params and we do dot transform underscore filter. So this connects the slider to the chart. These two lines at the last, right? These two, they connect the slider here to this particular chart, because that slider varies the year. Okay, so once that is done, the filtering takes place based on that, and we have the entire plot which varies using a slider. So we're able to visualize for each one of these years using Altair. Any doubts in this? You can put it on the chat or you can unmute and speak. Okay, so let's go ahead and we'll do the same thing using Plotly. I think I explained you Plotly as the most interactive method to display all these, and also in a web interface, and they have a lot of features. So you can see that it's more intuitive when compared to all of our previous plots. It's automated through these sliders. We can also move these sliders and start to play the animation. So you can see that it's extremely interactive with all of these options around. So let's go through this and see why how we are able to achieve this. So don't you think that this is the smallest uh, code that is able to do the same thing but also in a better way, right? So why is that and how is that? Let's go through the code. Um, when we start, we're going to just start with the totally of scatter because it's a scatter plot. Provide the data. We have x as income and log x equals to true. So that we use the log scale, right, to manage the wide income disparities. That is, we had it more concentrated towards the left, and now it's going to be done in a logarithmic way. Now we have y as life expectancy, where we set the range of x and where we set the range of y as well. Now, moving ahead, um, we set the size. The size would be population. Okay, this and the max size is going to be 55. So this size is for the bubble, right? It's not for anything else. It's for the bubble size, and the max size ensures that the largest countries do not crowd the plot. Otherwise, these large countries will become so big that it will overpower everything else. Hence, we are going to make this particular limit happen for the circles. Then moving ahead, we are going to base the color on the continent. Okay, and we have a color discrete sequence equals px colors qualitative t10. So by assigning that, we have a bright and distinct palette. Okay, so you see that all of these are bright palette colors. So that's why we are selecting that particular palette. Okay, and once that is done, we have hover name equals country. So when we hover the name on the top, right, we see child, and then we see Hong Kong, China, Jamaica. The heading of it, right, the hover name is going to be the country. Okay, now for the animation, we have animation frame equals here. So the chart automatically animates the entire chart from on the basis of the year. Okay, and we have the animation group equals country. This is so that the it keeps each country's bubble coherent over time and it doesn't jump around. Like you see that it remains coherent, right? Like if I create a different scale right now, it's going to keep moving, and it's going to, the auto scale also is going to change the scale continuously. In order to prevent all of that, we are going to have the automation group as country, and we have to set the width and the height as we do in any other plot. And finally, we have a figure.update layout where title has the title, x-axis title, and the y-axis title, which is as simple as possible. And finally, we have figure.show. So finally, we are able to create the same plot that we saw earlier uh, that was using Matplotlib, using so many more lines of code, which is much more difficult, into something which is not that many lines. It's just few lines, but it's much more interactive. It can be interfaced in a website. It is much fewer lines. It's easier to understand. It's easier to code. It's easier to remember the syntax also. So, however, Plotly has one small disadvantage that would be it would take a a much higher amount of computational power from the computers to process and create these compared to the other methods. But it also has a proportional amount of features which would be useful. Um, so yeah, so we're coming to the end of this particular first half of the session where we look through how the wealth of nations is going. So, do you guys have any doubts? Do you guys have any doubts?
Shamshad has asked processing power on the server side also, or just client? Server side mostly. For generation of the plot, it will take the server side of
No,
the
no, no.
computation.
The client-side processing plotly generates a HTML, CSS, JavaScript
Hmm.
representation of the chart. So it all
Hmm.
these will be generated towards the client side, not the server side.
The processing power that will be used is will be from the server.
No, it's from the client.
Okay.
Wait, am I wrong? Can you just check? Because
Okay.
since these are interactive plots, they generate and since it's adaptable to the since it's adaptable into a website, it will be
Hmm.
mostly towards the client side processing.
Actually, I have one example in the next notebook.
Okay,
So let us take it there
okay,
and
sure.
let the audience decide what where the computation is heavier.
Okay. So,
So
okay,
this
any
is
other
also
questions?
kind of a story. Uh, we will check it.
Yeah. Any questions with regarding wealth of nations? Okay, I hope not. So let's go ahead and I'll hand over the same thing to Purnendu. He'll continue to the next half of the session.
Okay. So I will start sharing my screen now. Yeah. So now we are on the day 4, the last day for this short course on data visualization with Python. So we have explored a real world data set, the wealth of nations data set, and we have done multivariate analysis on it with visual narratives as well. And Subhiksh has very intricately explained all these things. And now let us get into a story. I have a story for you, which I will tell today, and it will be related mostly to network science or graph theory as a fundamental. So let us start with what is a graph. So I know most of you have studied, but just to refresh, what is a graph? It is a set of nodes and edges, vertices or and connections, like, and the edges are between the nodes, and it is denoted as uh, a tuple of vertices and edges. So edge vertices will be a set, and edges will be a set of tuples from in which the elements of the tuple will be like vertex I to vertex j. Uh, such kind of tuple we will have in the set E. Now, so vertex is a fundamental unit, right? So you can think of it as a person in a social network, as a city, as a computer in the graph, right? And edge or the link or the connection is a relationship between those two nodes, right? So suppose in this Zoom meeting, so we myself uh, we have 10 participants here. Myself, Samantha, and Subhiksh. We three are related with the same support vectors company, right? While Christine, Dean, Eugene, John, Mike, and Samshad, they might be having working in different companies or running their own things, but it is possible that they are related or not related uh, professionally through any means. So one thing is sure that we three, Purnendu, Samantha, and Subhiksh, we are related. And when we are going to plot a graph of people in this particular Zoom call, and do they know each other outside the Zoom? If it is a yes, then we will put an edge between those two person. Otherwise, we are not going to put an edge. So you may have a disconnected graph in which there will be two or more parts in which V3 from support vectors will form some kind of a triangle, and others may not know each other. Such kind of graph is possible. So now, just if the data is represented in that form of graph, what do you think? You can instantly you can figure out who are from the same company, right? It will give you an overview. This is just a example that I have chosen for beginning with it, because this also relates to the story that we are going to uh, hear today. So there are multiple types of graphs: undirected, directed, weighted, unweighted, simple graph, or multi-graph, connected graph, disconnected graph, complete, bipartite graph. So I will try to give an overview of few of them. So uh, edges will have no direction if there is an undirected graph. Like if on on a social network, for example Facebook, if person A and person B are friends, then it has to be an undirected graph, right? There is no direction, there is no meaning of direction, right? A to B, there has to be just one line segment, that's it, one edge. However, if I follow someone, right, I follow that person does not follow me. For example, on X or Twitter formerly. So that has to be a directed graph, right? I follow support vectors will be an arrow from me to support vectors, right? That is how you can visualize it. So so uh, in directed graph we can also have bidirectional graph. Support vector can also follow Purnendu, so the arrow will be on both the ends, right? Weighted graph. If you want to have have like the number of posts that I have liked from support vectors, that can be weight of the graph, and that is how we can calculate uh, uh, the the person who has liked the most, such kind of thing. So the weight will put some capacity, some cost, or some numerical value on top of the edge. Unweighted graphs, it will all edges will be treated equally. So graphs can have self loop. I can follow myself. If I can follow myself, then it is not a simple graph, right? If I cannot follow myself, then it is a simple graph. Or we can have multiple edges between the same nodes, yes or no. If we cannot have those things, it is a simple graph. In a multi-graph, we can have multiple edges between the same nodes. So if it is a connected graph, there is a path between every pair of nodes. In our example of the people who are present in this Zoom call, if we make a graph, it is possible that it is a disconnected graph. So some nodes cannot reach each other, right? Complete graph in which every node is connected to each other. So and bipartite graph, it means that the node can be split into two groups, like in two layers in a neural network, right? So the such kind of graph is a bipartite graph. So with this, now you can get some idea of how real world can be and relationship in the real world between different objects can be mapped into graphs, right? So the node and edge has certain properties. The node will have some degrees, in degree and out degree in data graph, number of incoming versus and the number of outgoing going edges, right? So and the overall degree is the number of edges that are with that particular node. A path has to be a sequence bit of nodes connected by edges. So suppose from path A to path B, there has to be the sequence of nodes that has to be covered to reach B from A. That is the path. A cycle, when it start from A, travel the whole world and then come back to A, ends at the same node. The shortest path we have if we have multiple path between two nodes, we have to find the shortest path, and that is what uh, we use when we suppose have to deliver parcel or find the shortest uh, set of lights from point A to point B, like that. And the diameter is the longest shortest path between any two nodes. So let us get into network X. So before that, I would like to give you a brief overview. Uh, so if you are using this UV, you have to just use UV add network X, UV add pivot. So pivot we are going to look at it in some time. First, let us focus on network X. So network X is a library that will help you create a graph and perform certain operations on a graph. So after this example, I will go a little bit deep into network X to give you an introduction of it. So right now, let us have a look at this particular example. So network X is imported as NX mostly. So if you just write graph, it will create a simple undirected graph, right? And you can have a list of nodes and then you can add nodes from it, right? And then add edges has to be a list of tuples, and the tuple will be like the vertex 1, vertex 2, the start and end vertex of that particular edge, right? To and from. So if you remove this from, then you have to give each each node iteratively, right? So uh, just annex dot draw and then pld dot show. So actually, this network X by default it uses matplotlib. So that is why you have to import matplotlib pyplot to show the graph. So annex dot draw will draw that graph for you. So this is the uh, graph that we have drawn. Simple graph, very simple, right? Undirected graph. Okay. So now let us get a bit more into network X. Graph theory and network analysis library. So it cannot just create graph, it can run algorithms like shortest path, page rank, centrality, detection of community and all. So for just creating a graph, you can use these particular methods available and give the lists and nodes and all. Now getting into pivots. Uh, Before that, let us have a look into this. Okay. Mm, hmm. This we are going to use it after some time. So just we have imported it. So this is the aesthetics part, which we already know, setting the DPI size, the plotting style to use, the font family, use of tech is equal to true and all for LaTeX type rendering and all. This is well known. So there is a well known network called a star network, so, which is a star topology in which there is one hub node and all are connected to it, right? So this you can have you have examples about this on star topology is famous in computer network, right? Like when your and a set of laptops and mobile phones are connected to a particular router, then it is a star topology network, right? So what we have done, just we have taken the number of hubs, so number of nodes, that is number of outer nodes, and we have created a star graph using the inbuilt functionality available in network X, and then we have just plotted it, just drawn it. Okay, so we have this star topology network. So now getting into this Pivot thing, Pivot helps us visualize it very well. It is very modern, and it makes it very aesthetic. And so Pybase is also a Python wrapper on top of Viz.js, which is a JavaScript network visualization library. This makes it very interactive. Runs in browser, and then supports a lot of functionalities. And it also gives you a very nice control panel, right? So for understanding this particular piece of code, so let us have it here. So next to a star graph, and you give the we are working with the same star graph that we have created using network X. So Pybase will not create a network for you. It will PyX will not Pybase will not create a graph for you, but it can visualize the graph, right? And then you have imported, see, from Pybase.network import network. So for Pybase functionality, we are going to use this network to instantiate the Pybase network object. So net is what? Net is now the Pybase network object, right? Which has some parameters, height, width, notebook equal to true. It means it will render in the notebook itself. And CDN resources inline. What do you think is the CDN resources? Any guesses? So these CDN resources are actually Pybase uses JavaScript, right? As you see, it chooses this Viz.js and some supporting JavaScript libraries. Those are available in the content delivery network, right? CDN, and that is what CDN resources is. It has been set to inline, so it will generate the whole CDN. It will not like get it from somewhere while loading. So it will be generated in that particular file. So now what happens is from NX means from the network X, there is a function from with the network. So net dot from NX star, it will convert the network graph into the Pybase network object. Okay, and then if you want to show the control panel, I will show you what the control panel looks like. So it will show buttons. So it will show everything. It enables a control panel in which you can increase the size of the graph and all those things is available, and it will convert everything into this star network.html into this file, and then you can have a look at it, right? So if you are using in so it is shown here inside the v Jupyter notebook. Depends on where the Jupyter notebook is running. I am running it on VS Code. So if you are using a browser to use to look at it, it is possible that if it fits, then it can be shown here. However, uh, we can like open the tab graph in another tab or another window, right? So we have the graph, yeah, this generated here, star network.html. Okay. So this is the star network that has been generated. Just refresh it. Okay. Some other style format visualization is there every time, right? You can now drag it, right, as per your wish, and see how it adjusts itself, right? And then you can zoom into it, and border width, you can border width of this particular uh, border of the nodes. And if you select it, and then you can work with the border width and decrease the border width like that, just to highlight all of them. So right, these are things that you can do. Border color you can choose and apply, right? There is a host of options that you have, right? So a lot of things are there that you can explore, play with it, and see how the graph that has been rendered can be customized, right? Mm. Now coming to a complete graph. What is a complete graph? In which all the nodes are connected to each other, right? So complete graph, suppose you are in a classroom, you are in a school and there are multiple classrooms. So in one particular classroom, everyone knows everyone else. So that in that classroom, if you plot a graph for the classroom, and the edges will be the and the vertices will be the each student, and the edges will be if person A knows person B, right? So that will be a complete graph, right? However, if you plot it for the whole school, then there will be small subgraphs that will be complete, right? And those are called clicks. A small subgraph that is complete is called a click. That also have some relevance and importance in network science. Okay, let us have a look at the complete graph. So you want to start a complete graph of this 20 nodes, right? So okay. Hmm. So for that you can just use complete graph. And so star graph we have used. Now we are looking at complete graph. So for a complete graph, it is very beneficial to have a circular kind of layout. So you can choose circular layout. This POS is used. This is for positioning of the nodes. So this when you choose this circular layout of this complete graph, then you actually choose uh, set the positioning of how the nodes are going to be spread in the visualization. So we will first draw the nodes, and then we will draw the edges. We will not draw it together because together drawing it together will make them have the same color, and we that will be not looking very nice. And like so, draw network X nodes, and this is for edges, right? Complete position, and you can change the alpha or the transparency and edge color, right? Node color and here edge color. Okay, and then plot it like this. This beautiful graph we have got. Such kind of graphs are always the book cover of a graph theory book. You must have noticed that as well. So now the story, right, of Zakari's karate club. What happened in like 1970? There was a university in the US, and there was a karate club, and there were many members of that karate club. There was one instructor and there was one administrator, right? They had some I mean arguments possibly, and they had differences on how the karate club should function, how it should work. So slowly and slowly what happened, there was some people who were more fond of the administrator, some people were more fond of the instructor, and the the club separated into uh, two parts, split the club split into two parts. So this example was used, this data actually, Zakari was let me open it, open the Wikipedia page for it, right? Zakari Karate Club Wikipedia, right? This is very famous example actually. So this Wayne Zakari was the person who was actually studying this whole karate club, uh, and was collecting data of who is interacting with whom. So uh, these ages that you see between 7 and 12, right? So if there is an age between 7 and 12, it means that 7 interacts with 12. So such kind of information he was gathering, and based on the interaction, he gave certain value to the edges. Right, so it is a weighted graph now. Edges will have weights. So there were 34 individuals, which includes the the administrator and the instructor of that karate club. So this example is so important that this established the use of graph theory in real world uh, uh, society, in real I mean human interactions, and and a model to understand human interaction, and how political parties is split, how karate club split has given an insight into how political parties split, how nations is split, and so on and so forth. This example was such a seminal work that it is now it is a part of the NetworkX library. That is also one important thing. Okay, so the thing is, let us create this karate. What is this karate? Is a network, right? Is a graph. Right? So nx.karate club graph. So you can also explore more on it. Okay. Hmm. So the nodes, I am just printing out the nodes just for clarity. So 0 to 33, 34 nodes are there, and like 0 to 1, I am just printing what are the dot nodes will give you the nodes, dot edges will give you the edges. Now I'm just printing it, right? So this is the weight 0 1, between 0 and 1 weight is 4. Matlab, it means more interaction, right? 2 means less interaction, 1 means least interaction, and like that. Okay, just to describe how the data is. So for Zakari's Karate Club, we are going to use this spring layout, uh, just to position the nodes, and then draw the nodes as we have done previously in the complete graph, and same for the edges, right? So this is how the graph is. Okay. Okay, now let us have a look at it with Pybus, right? No, before that, let us have it for in a different layout. Everything is same. That's just we have changed the layout. So now have a look. Can you immediately figure out who is the most influential person in this graph? So I think these two, right? This person and this person can be the uh, and they don't interact amongst themselves. One can be the instructor and one can be the administrator, and and the and so it is mostly split into two parts, right? Although there are some I mean connections here and there. This gives you a visual representation of the uh, uh, how the split happened, right? Actually, so now let us have a look at this how to generate it using Pybus. So Pybus, we are creating this Pybus network object and from annex karate, and then we can show buttons if we wish. So this is what we have. Okay. So the weights are the higher weights are like higher have thicker lines, right? So see how good this visualization library is. It is very interactive. So you can just see that there are like two groups, two clusters forming. One is this one, and the other one is this one, right? And where are the power centers of that cluster? Those things you can analyze. Okay, let us get to this Facebook now. So we have socialized in past with events, and then people started living in bigger society and bigger, and then we globalized, and then we had social networks, right? One of the most important social network was Facebook, right? Although we had Orkut and other things before that, but Facebook was a real game changer. So we have this data set from Facebook which we want to use, and this has some age list of like friends. Uh, if there is there is a friendship relation between two nodes, then it is an edge. So we can just have the edge list, and from that we can infer the vertices, right? So create a read edge list. From that we are using an extra graph to create, and node type will be some integer we can put, and then it is in this particular uh, this graph social, right? Just printing the number of nodes, and then so we have a 4039 nodes and 88,234 edges. That is a lot, isn't it? So let us visualize it using the simple network X. So just draw the nodes and draw the that particular edges, those edges on in a spring layout. So this, right? If you can see the full graph, now I think you can see the full graph. So this, what do you think this can be? Suppose this is a data from my set of friends on Facebook. all my friends on Facebook, and the link is if they are friends or not. So this can be my these set of nodes can be my relatives, whom who all who they will know each other by default. This can be, oh, there is a message, school cluster. This is not exactly the school cluster. Yeah, this particular thing can be a school cluster, because some of the relatives, they will also be in the school, right? This, I think, there is a freedom for interpretation, right, Shamshad? So this can be our relatives, or school, and higher school, and then suppose I did bachelor somewhere, master somewhere, job one, job job two, job three, something like that, right? Those kinds of clusters can be there. Or this particular club I am member of, right? They will know each other very well. So those inferences we can derive. So now, processing power on the server side or the client side, right? So this caveat emptor we have, we can visualize it during Pybase, but it will take a very long time. You can try it out to visualize same thing using this Pybase as a homework. It will take a very long time, so that we cannot take it here in this session. It will not end in this session. So because the number of edges is very high and the number of nodes is high. Yeah. So that this is also one thing to explore, that the processing power is on the server side or just the client side. So the Pybase, what it does is that it generates an HTML file, if you remember, right? It generates some HTML file. The generation of that file, that will take a long time. However, if you the file is being generated, so that will not take too much resources on your browser to run. Although if the network size is too large, so it will have its implications. So there are now coming to the final thoughts, right? We can have, once you get a taste of it, you would like to go deeper into it. I tempted to cluster network nodes into communities. Detection of which community it is, right, is a natural question to ask. So from graph theory, network science has evolved. So we now have a rapidly evolving field called network science, which studies social networks and all kinds of networks, right? So if one is more interested, one is more than welcome to go through this book on network science. So such a good visualization, right? JavaScript. You can even cut the nodes from here. See, right? So Barabasi's book is the first place to start with. So that brings us to the end of this 4 day course on data visualization with Python. If you would like to share anything, if you want to ask or discuss, please go ahead. Now we are open for it.
So these are good concepts. Like, how do we practice and become good at this?
So the first thing is to, I think, start with some project, get some data set, and we can start playing with it. I myself started with my own Facebook data, and but at that time the Facebook data was easily available. You can use some APIs to download the data and plot it. Plot we can plot it. Such kind of graph was easier to do. Now also many places you can find data sets. So having a real data set is the best thing to start with. Once you have that, you can do some basic exploratory data analysis on it, and with that you will be able to figure out what questions come to your mind, and we can try to solve those questions. This is for learning about it. And for network science, one very important thing these days is fake news. How the fake news spreads, that is also a network science problem. So those things can also be explored. How how content goes viral, network science has to do with that as well. How the I mean network science also can be applied into designing neural networks. So a lot of things can be explored, like the networks in your brain as well. We can think of creating a graph of the parts of your brain that that get activated on a particular set of visual inputs. They are related. So the to summarize, we can start with data sets on Kaggle that are available freely, and then we can collect data sets. Try with our own social network data and Twitter data, Instagram data. Those data we can use to have a good uh, understanding of this, and then we can then try to gather real world data and apply network science real time. Hope that answers you, Shamshad. Eugene, I am really sorry that you had to visit there, but you were not, no one was there. So, is it comfortable? How are you attending the session right now? I'm okay. Hmm.
Purnendu, can you go through that website, our course website?
Yeah, yeah, sure. So, with this, we are shortly starting our boot camps and LLM fundamentals course. You must uh, have looked at our this LinkedIn posts and all. So new courses are coming on the way, right? So so this is the foundations of AI starting on 3rd June, right? LLM boot camp on 7th June. AI agents on 1st June. So these things are starting, and like these are really important because let me go to one slide, right, that I have not discussed in detail, because that is what the future is, and even that has become the present now. Not that's not the future. The future is AGI. Okay. Yes. A brief history of data visualization. starting with 1644. Some statistical graph was made by Van Langren, and then see Matplotlib, Seaborn, John Tuckey. We have seen the first quote was started from John Tuckey, Florence Nightingale, John Snow, cholera map we have seen, and all these things. Matplotlib, Seaborn, Plotly, Altair, and then now the thing is LLMs and AI can generate and reason with directly visualizations which humans could do. They don't just need the whole data set. With the graph you plot, they are able to understand it and reason on it, on top of it, ask questions on top of it, see what are the anomalies from the image that you give to the LLMs. So now the thing is LLM is the thing, right? So we need to go deeper into it. Foundations of AI, neural nets, LLM, and generative AI is one thing you can go ahead with. And LLM bootcamp is is a very intensive. So these things will really shape your understanding of LLMs. So these things you can explore, and you can even reach out to us, and then you can enroll in this starting very soon.
Okay, and if I may add, sorry, the foundations and the AI agents will be moved, pushed back for 1 week. So
Okay,
foundations will start on June 10th instead of June 3rd, and AI agents will be on June 8th.
okay. So
The
that
others
is
will continue
hmm,
as is. Yeah,
okay. So that is one announcement. So this we are extending by a day. Sorry, by a
by
week.
a week. Yeah.
This as well as a week, by a week, and this will start as scheduled,
Yes.
right?
Yes.
And I think the first class is open to everyone, right,
Yes.
Samantha?
The first class is
The first
free.
class is open for
Mm,
everyone. Yeah, you can get
so
into it without having to buy the whole course. So that also you can have a taste at it. Everyone is welcome for that. If you would like to give some feedback, or if you would like to uh, ask any question, please go ahead. Okay, so I hope this has been interesting, and I hope that you are now a bit more confident about visualizing data. At least you now have the skill to understand how to plot it, and then you can even supervise or use it directly in your with your own hands. Okay, I think Subhiksh, would you like to give some uh, ending notes?
Yeah, so the session was really nice and insightful, whatever you shared. So hope to see you guys in our future courses, and I think that's it.
Okay, then thank you everyone.
Thank
Even
you.
if I think you all are in that Discord channel. Even if you face any difficulty, please ping us there, right? We would be happy to help you out. Okay, thank you everyone.
Yeah, thank you guys.